A chance to see some snow the other day. We even had a day off of school. Here's a picture from the evening before they called a snow day for us. But yeah, what fascinates me about water, really, and snow is just kind of what makes each of these little snowflakes individual. To me, that's crazy that there's so many flakes, so many crystals, and each one is unique. In a lot of ways, you can relate these unique aspects of snow to the special properties of water. So, once again, I hope you kind of liked our snow day. Here's just a little picture of some of the snow from outside my place. And let's see here. I kind of always tell my students that all knowledge begins with wonder. So just thinking about the snow, wondering for a moment here. Along the way, we'll kind of get an introduction to the physics of water, liquid physics. It's quite a fascinating subject. We'll talk a little bit about Mount Everest and some of these adventures and some of the tragedies and stories that have happened up there. We'll also look at just kind of what it means for hypothermia to occur. So we'll look at Bill Bryson's book, A Walk in the Woods. We'll read excerpts from John Krakauer, Into Thin Air, which is really what that Everest movie was all based on as well. So, once again, I thought we were kind of fortunate to get a snow day here. And just bringing in little bits. Now, I think we got about 2 inches of snow. And what kind of fascinates me is just how there was different amounts of snowfall throughout St. Louis. And there really is kind of a challenge to measure the precipitation. And I don't know if you've noticed in our journal entries and just the way the weather underground sensors work. We'll kind of look at that and really what it means to be 1/10 of an inch of precipitation or more or less. So, yeah. So here, once again, we're going to get a kind of a close-up of a lot of these snowflakes. And I'm thinking maybe we can even bring microscopes into our class and see if we can gather up some snow and get a microscopic image of some of these flakes. This is just with my iPad, but already you can see how some of the snow is melting fairly quickly, while other flakes kind of stay solid. Well, what makes these droplets melt real fast? Why does the paper absorb it? Why does the plastic repel it? Why is it reacting differently on the ceramic, on the tile, as it does on the glass, versus the different types of paper? We got the ice crystals on the metal. Just this interaction of all these different materials really is kind of quite fascinating. And I guess in a lot of ways what makes the weather very fascinating as well. Okay, so thanks for kind of taking a little tour of the snow I brought into the house and just kind of dumped it around on some different materials there. Okay. So once again, you can kind of get a peek of all of that. Now hopefully you're kind of working on some of these questions as you do this. I believe you should have got a worksheet that looks like this snow day, intro to precipitation and special properties of water. So yeah, our snow day, when was that? It was Wednesday, January 20th. I'm just curious, what fascinates you about snow? I always kind of tell my classes, all knowledge begins with wonder. What do you wonder about when it comes to snow? In just that little short movie, you kind of saw a lot of these properties of water. We'll always compare them to those other materials, whether it be the plastics or the metal or the paper, the ceramics, the glass. They all kind of behave differently than water does. And we'll look at a big thing is, why does water expand when it freezes? No other materials really do that. That really is a very unique property of water. In other words, just ice floating, kind of we take for granted. But yeah. Okay. So hopefully you've kind of started to take a peek at that a little bit. And we'll kind of look at, so here is what, 3,000 meters. That's about 10,000 feet up in the air. 10,000 feet. Mount Everest is close to 30,000 feet. So just a third of the way, even a lot of these base camp they're talking about, that's up here at like 10,000 feet or so. Where if it's below 0 Celsius or below 32, when precipitation falls, it's going to stay frozen. It's going to stay solid. And just the way that base camp compares to the top of the mountain, there's great stories in the book Into Thin Air that we'll read some excerpts from. We'll read some excerpts even about just going up a mountain in New Hampshire. And it was only about 5,000 feet. So yeah, right about here at this altitude, and what it was like to walk through a cloud, and walk through a cloud where there was ice crystals, and this was only about 5,000 feet compared to the Everest. So we'll really kind of look at how the pressure changes and how that affects water as we go up in the altitude. And that's kind of I think a first step in trying to understand all these different types of precipitation. And it really is fascinating. The physics of liquids, people say it's the physics for poets. It's a very unpredictable and a very fascinating topic. So please recognize these special properties of water. And we'll be doing little experiments to kind of help you recognize how important those are. Just even looking at these snowflakes, trying to see them on the gravel there. And then this idea that, what makes the water, what makes this ice just here floating on this very, very thin layer of water on the tile on the floor. It is quite fascinating, the fact that ice does float. So here we go. We had this snow day, and it was really, I know, at least where I was, and it's really close to school, about 2 inches. About 2 inches. So there's another spot. We just stuck a ruler down, just about 2 inches. This was about 10 o'clock in the morning. So I just scooped up, I don't know, it's not great, but I just scooped up about 2 inches. Looking back, maybe it'd be best to just let it fall in there instead of scooping it. But let's say here we got about 2 inches. Here's that same 2 inches 10 minutes later. 10 minutes later, or no, 5 minutes later. Here it is. It's just melting. It's just snow melting. There it is 20 minutes later. 25 minutes later. Half hour later. So it was up over that 1 cup mark. It's melted. The water's still there, but yeah, there it is a half hour later. Then I came back about 10 or 15 minutes later, and it was like gone. You can see a little bit of slush in there in the bottom. But then trying to measure that amount of water, it's hard to see because of the refraction of the glass, but there's a little price tag, a sticker here that got pulled off. The water level was below that kind of leftover glue from the sticker. So here, let me just show you on that ruler. There it is. It was like really barely even registered on the ruler. I'd say just less than a tenth of an inch, less than an eighth of an inch. So all that snow melted down to hardly any liquid, any moisture. Crazy.